In this tutorial, I'll be speaking about Rust iterators, just to get your feet wet. This tutorial contains two examples, both of which do the same thing. However, the first example uses iterator adapters, so this example, and the second example is written in a procedural style and avoids the iterator adapters, but it's the same code. This code comes from a scripting language compiler which I'm writing in Rust. And the purpose of this particular function is to return the line number of where the main function starts in the script. These examples don't actually return the line number, they simply print them out for the sake of simplicity. So it's this first example, the iterator example, which uses the iterator adapters. So let's have a look at this example. The first chunk of code simply stores the lines of code that are to be processed by the actual iterator. This code would not actually be present in the function, but for the sake of this illustration, I've just included it here. This iterator uses 5 main iterator adapters. So the first iterator, which is iter, what that does, it converts the string vector, which is up here, into an iterator. And that's necessary so that the iterator adapters can actually be used on the actual data in the vector. The second iterator is enumerate, which returns 2 values as a tuple. The first value is the actual index of the data stored in the vector, and the second value is actually the actual data itself. The filter adapter is pretty interesting. What it does is that it filters each particular value as it is cycled through in the iterator, and if the value is true, such as in this case when it equals main, then it lets it pass through, so it's included. But if it's actually false, then it just skips it. So you can see how that could be a very powerful tool in your code. And one thing to note about the filter adapter is that it accepts Boolean values, either a true or a false. The map adapter, which is heavily used in iterators, is actually what in this case replaces the for loop. So by using this adapter, you can cycle through the values of a vector and do something with each particular value. In this case, map doesn't do anything except pass on the first value in the tuple, so it's almost like a multiplexer. But you could, for instance, change the value. You could increment it by 1, or you could change it from usize in this case to a string. And as I mentioned, the map adapter is used heavily. The final adapter is collect. The collect adapter actually makes everything happen in the sense that it activates all the adapters and finally returns the result as a vector of usize values. And one thing to note about the collect adapter, it relies on this vec usize. If you don't include that, then it simply will not operate. It needs that value. One thing you could do instead is, instead of putting usize there, just put an underscore, and it will often be able to determine what value you need. But in my case, I put usize because I'm not actually specifying a return value, so it doesn't know what to put there. But if I was to return results of search, then the compiler would know automatically that that is meant to be a usize. One thing to note about the collect adapter is it reminds us that by default iterators in Rust are lazy. And that term lazy is actually a technical term, I didn't make it up, and it means that no code is executed until it is actually needed or used. And this means that code that's not necessary to be run doesn't run, and it makes our code more efficient. Haskell, for instance, is lazy by default as a language. And you'll notice a lot of these adapters actually come from functional languages. And if you look at the iterators in Rust, such as zip and all these things, all those particular adapters are also present in a language heavily such as Haskell. So what happens is the final results are tallied up, and they're included in the result of search, and then you have you would normally return those values. If you have a look at the procedural code, it actually does the same thing, but it doesn't use adapters. I mean, it uses one adapter, iter, simply just to cycle through the code, but I just include both lines of code or both functions just so you compare what one does versus the other. And I'll also include this code sample in the description above the video. I hope that you found this tutorial helpful. Thank you for watching.